Welcome back to Sum and Difference Identities. In this section, we're going to be covering more identities because they just keep on coming. And we're going to see if you can find proofs for these in your textbook. Most textbooks will show the proofs for addition and subtraction formulas. Let's look at the formulas for sine. If you have two angles, S and T, and you add them together, and you want to take the sine of the sum of those angles, you can use an identity stating that sine of angle S plus angle T is equal to sine S cosine T plus cosine S sine T. And if you use sine of an angle minus another angle, so sine of S minus T, you'll get sine of S cosine T minus cosine S sine T. There you go. There's your first set of identities. The next set of identities or formulas for cosine are cosine of S plus T equals cosine S cosine T minus sine S sine T. And cosine of S minus T equals cosine S cosine T plus sine S sine T. Now, if you're trying to wrap your brain around how in the world are you going to memorize these, one of the things you might notice is that the sine identities almost always behave nicely. They have nice formulas. And you might be thinking, Sarah, what are you talking about? These are not nice formulas. But these are nice formulas because you can find nice patterns. What I mean by that is if you have a plus here, you get a plus here. If you have a minus in the sum or difference, you get a minus on the other side of the equal sign. And it's always sine, cosine, cosine, sine, sine, cosine, cosine, sine. But when you get to the cosine functions, they do weird things. When they're pluses, then they're minuses. When they're minuses, then they're pluses. And you have the cosines sitting all by themselves and the sines sitting all by themselves. So sine usually behaves and the cosine is your problem child. So now let's look at the tangent identities, or formulas for tangent. Formulas for tangent are tangent of S plus T equals tangent S plus tangent T, all divided by 1 minus tan S tan T. The other one is tangent of S minus T equals tangent of S minus tangent of T, all over 1 plus tan S tan T. Now, that grouping could also be written as tangent of angle S plus or minus T equals, now notice that when it's plus in the sum of angles, it's plus in the numerator and negative or minus in the denominator. And on the minus, it's minus in the numerator and plus in the denominator. So the denominators are opposite. And so occasionally, if you wanted to memorize this in a slightly different way, you would have tan of S plus or minus. Notice that the plus or minus has the same order in the numerator, tan T, all over 1 minus plus. Now you can see that the opposite is true here. We flipped which one is on top. So it's minus plus now, which means that the signs are opposite given the sign of the sum or difference inside the tangent. Tangent S times tangent T. This is a very useful formula, especially in calculus. Make sure you memorize this. Make sure you memorize all of them. You have to memorize all of them. I don't know why I'm saying that. Memorize all of them. Now we're asked to find the exact value of the following. Cosine of 15 degrees. Now, cosine of 15 degrees could be broken up into angles that we know. The first one we could think about is like, how in the world are we going to get 15 degrees from two angles that we're very familiar with? Well, we could do 45 degrees minus 30 degrees. Both of those angles we're very comfortable with, and the difference between them is 15 degrees. So now we can write the identity or formula on the right. Cosine's the trig function that doesn't play well with others. So we have a cosine of 45 degrees times cosine of 30 degrees plus, because again, it's opposite here. And then we have to put the signs by themselves because cosine doesn't like them. Plus sine of 45 degrees times sine of 30 degrees. And now we just replace this with what we know about values for cosine of 45, cosine of 30, sine of 45, sine of 30. So let's just replace these. The cosine of 45 degrees is square root of 2 over 2. Cosine of 30 degrees is root 3 over 2. Plus sine of 45 degrees is root 2 over 2 times sine of 30 degrees, which is 1/2. Simplifying further, we get the square root of 6 over 4 plus the square root of 2 over 4. Combining these fractions together, we get the square root of 6 plus the square root of 2 all over 4. I would like you to practice leaving these as exact numbers. It's approximately 0.9, but I don't want you to do that. I want you to leave it as this rather ugly but exact number. Let's see if we can find the tangent of 7 pi over 12 using our sum and difference formulas for tangent. Is there a way we could rewrite tangent as a sum or difference so that it's a little easier to calculate? Well, let's see what we can come up with. I'm fairly comfortable with pi over 3 and pi over 4. Those are fairly common angles. And if I were to get a common denominator, I'd have to do a 4 over 4 and a 3 over 3. And hey, look, that would give me a denominator of 12 and a 4 pi in the numerator plus a 3 pi in the numerator. That would give me a 7 pi over 12. Hey, look, that's what I need to use. So I'm going to take tangent of pi over 3 plus pi over 4 and use the formula that we had previously, that we talked about. So the formula says take tangent of the first angle plus tangent of the second angle, and then do the opposite, so in the denominator, so 1 minus the product of the two, tangent of pi over 3 times tangent of pi over 4. Tangent of pi over 3 is the square root of 3 plus tangent of pi over 4 is 1, all divided by 1 minus square root of 3 times 1. We can simplify that further. The square root of 3 plus 1 over 1 minus root 3. Since this can be simplified further, it will look so much better if you rationalize it. We're going to go ahead and rationalize it. So over here on the side, I'm going to make a little box. So we're going to rationalize this fraction. We have root 3 plus 1 all over 1 minus root 3. So we're going to multiply by the conjugate. That will be 1 plus root 3. And we'll get root 3 plus 3 plus 1 plus root 3. That's the numerator. In the denominator, I'll have 1 minus 3. And now if I simplify this further, I will have a root 3 and a root 3, so that'll be 2 root 3. And I'll have a 3 and a 1, that will be a plus 4, all over negative 2. If we break this up into two fractions, we'll have a 2 root 3 all over negative 2 plus a 4 over negative 2. What this tells me is if I reduce these fractions, my final answer will be equivalent, this weird looking fraction we had originally, is now equivalent to negative root 3 minus 2. This is a much nicer answer. It's easier to work with, and I would not want a decimal. I want this nice, you might not think it's nice, but this beautiful, beautiful exact answer.